Good day, everyone. Today I'll be discussing about shear strength, and this is part of the chapter 7, which is the simple connection. So, we have learned from the previous reporter na the bearing strength of the fastener is independent to what type of the fastener. However, sa shear strength kay dili like magmatter yun ang type sa fastener nga gamiton. And from the chapter 7.2, we learned that shear load is on the bolt is equal to FV equals P over A, or kaning FV mo na siya ang average shear strength, and then kaning P kay mo na siya ang load na gi-exert sa each fastener. Then ang A is the cross-sectional area of the fastener. So ato na siyang reassemble, we have P now is equal to FV over AB, where ang kaning FV mo ni siyang shearing stress on the cross-sectional area of the bolt, and AB is the cross-sectional area of the bolt. And then, when the stress is at its limit state, the shear load is the nominal strength. So therefore, ang ato ang equation nga P equals FV equals AB, kay now mahimo og Rn equals, or nominal strength, or equals FNV over AB, where FNV is the nominal shear strength and AB is still the cross-sectional area of the bolt. So next, we have two groups of high-strength bolts. We have Group A, and these are ASTM A325, F1852, A352, and so on. And Group B is or are ASTM A490, F2280, and A354 grade IBD. Rather. So for comparison, ASTM A325 from Group A and ASTM A490 from Group B are both traditional high-strength bolts and are covered in the specification for structural joints using high-strength bolts. However, ang kaning ASTM A490 has higher ultimate tensile strength and has also higher nominal strength when compared to ASTM A325. And ang katong mga other bolts nga na-listed in groups A and B have the same strength but have special distinguishing characteristics. So, for example, instead of referring to an ASTM A325 bolt, we will call it Group A bolt. So, kibali, ang sa further nga to ang mga examples gikan sa tong reference, if magkuando ta, ato ra daw gamiton instead nga kaning A325 or other kuan, ato ra gamiton is kaning ilahang by group, like ato siyang tawagon if in Group A. And if kani po itong gamiton nga kuan, like kani siyang ASTM specification, ato ra siyang i-generalize into Group B. So, we have here the several modification factors of the nominal strength, or nominal shear strength rather. First, the ultimate shear stress is equal to the 0.625 times the ultimate tensile stress. So, kibali, ang ato ang ultimate shear stress now is the 0.625 sa ato ang ultimate tensile stress. Next is there is a length factor of 0.9 for connections no longer than 38 inches. And if manlapas ang connection or longer connections, ang ato ang factor nga i-reduce is 0.75. Next is if the threads are in the plane of shear, use 80% of the nominal bolt area. However, dili nato i-apply ning 80% ka bolt area directly kung mag-compute na ta sa nominal bolt area. Instead, ato siyang i-apply applying this reduction directly to the bolt area, then should apply. However, a factor of 0.80 is applied to the FNV, or katong nominal shear strength kani siya. In this way, the nominal bolt area can be used whether the threads are in or out of the plane of shear. So, when it is not known whether the threads are in the plane of shear, assume that they are and use the lower shear strength. So, pasabot anik if ang problem kay wa siya nag-ingon dito akong kuan ba, if ang threads ba daw kay naa siya nasa plane of shear or wala, ato yung assume nga naa siya sa plane of shear. And ato ang gamiton nga shear strength ay katong pinakaubos. Okay, if mag-solve ta for the design strength and allowable strength, so for the LRFD, ang ato ang resistance factor nga gamitin is 0.75. And ang ato ang gamiton na design strength is VRN is equal to 0.75 times FNVAB. So, mapapansin ninyo, ibagay na is RN equals FNVAB. Karon, ang pagkuha na to sa design strength is just VRN. Ang phi na to, sa mga to resistance factor gali, 0.75. So, VRN equals 0.75 FNVAB. Whereas, if mag-solve ta og for ASD, ang ato ang safety factor is 2.0 or katong kaniong horseshoe is 2.00 or 2, and atong allowable strength is Rn over omega is equal to FNV over times AB all over the safety factor, which is 2. So we have here an example. Determine the strength of the connection shown based on the bearing and shear of for the following bolts. So, isolve na to diri ang bearing o ang shear strength sa A36 steel nga ay duha ka bolts. First is atong isolve for the following bolts. We have bolts nga na A307, then bolts nga group A, which is ang threads in the plane of shear, and another group A, pero yung threads kay wala sa plane of shear. So this is the solution. First is i-identify sa nato ang hole para ma-solve nato yung bearing computation. Kaya problem, atong pagkitaon isang bearing strength o ang shear strength. So, pag-determine nato sa H or ang hole, diameter sa hole, nabala nato to sa katong previous topic nga ang gamito nato ana is just the diameter plus the 1 over 16. Di na ito mapinunto ka sa roughness nga 1 over 16. Ang ato rang gamiton is just the 1 over 16 nga isa, and di na siya mahimog 1 over 8. So, H now is equal to D plus 1 over 16. So, sa kanitong problem, we have a plate that has a dimension of 7 over 16 by 2 1/2, and the gusset plate has a thickness of 3 over 8 inches, whereas ang ato ang bolts kay na siya center to center space nga 3 inches, and then natay edge distance to center nga 1.5, and both ang ato ang kaning tension member gato ang gusset plate kay A36 steel, and ang ato ang diameter sa bolt is 3/4 inches nga bolt. So, we have now, ato ang D is 3/4, and i-plus nato siya 1 over 16. So, therefore, ato ang H is equal to 13 over 16 inches. Then, isolve din nato ang LC, or muna siya ang edge distance to center sa ato ang bolt. So, pag-solve ana is ato lang i-minus ang LE sa H over 2. So, atong LE muna siya ang edge distance gikan sa kaning gusset plate o sa center sa imuhang bolt. So, we have now 1.5 minus atong bagong nakuha sa hole, diameter sa hole, which is 13 over 16 all over 2. So, we have LC now, or edge distance to center, nga 1.094 inches. Then, we can now solve the bearing strength. Muna siya ang equation. If matandaan ninyo, gikan sa previous nga report, nominal strength is equal to 1.2 times LC times T, or the thickness of the gusset plate, times the FU. Ang kining FU is makuha na to ni siya sa katong nominal strength or ang grade sa tungkuan sa ato ang steel na gigamit. So, since A36 man siya, ang atong gamit is English man na unit. So we have now ato ang FU is 58. So ato nang kung anong product, we have now the nominal strength which is equal to 28.55 kips. And kung na to ang maximum niya nga value, we have 2.4 dtFu. Ang kaning d mo ni siya ang original diameter sa bolt, d is the thickness, and FU mo get na siya for the A36 steel. So 2.4 times diameter sa bolt, which is 3/4 inches rather, and the thickness, which is 3/8, times the FU, which is 58, we have now 39.15 kips, which is greater than sa ato ang nominal strength nga Rn, which is 28.55 kips. And ato ang gamiton anis ang mas mubo sa duha. So therefore, ato ang bearing strength na gamiton is 28.55 kips for sa kato nga bolt. So sa next nga bolt, kay since naman ta ka bolt no, sa kani nga bolt we have edge distance sa center equals ang kaning spacing sa center to center space sa ato ang duha ka bolts minus ang hole, isa ka hole kay kani man kani to kani dayon minus ani mo og half ani equals isa na siya ka hole. So mo to nga spacing minus hole nga 1/2 plus 1/2 equals isa ka hole. So we have spacing na 3 inches minus 13/16 nga diameter sa hole. So LC is equal to 2.188 inches. Then, balik na to atong formula sa bearing strength, which is Rn equals 1.2 LC times thickness times Fu. We have now the nominal strength, which is equal to 57.11 kips. And isolve din na to ang upper limit niya, which is the same equation na gigamit sa gain na 2.4 dtFu. And nakuha na to is 39.15, which is less than 57.11 kips. And ato ang gamiton is mas gamay, so kanima nang mas gamay. So ato ang gamiton is Rn is 39.15 kips para sa katong. So next problem sa A nga problem, is na natin bearing strength, isolve na nato ang nominal shear strength. So first is akato sa A306 ba to? A307 rather. So first is ang A307 nga bolt. So we have now Rn is equals to FNVAB, or nominal strength is equal to nominal shear stress times the cross-sectional area. So the nominal bolt area is equal to kaning AB, cross-sectional area ko na siya, pi over 4d squared. So ang ato ang diameter sa bolt is 3/4. So pi times 3/4 squared over 4. And this results to 0.4418 inches squared. So for A307 bolts, ang iyang nominal shear strength is 27 KSI. Nana siya sa katong table J 3.2 sa AISC. Kamo ni sa table J 3.2. Dayan mo to siya bolt nga A307. Then, ato is muna siya nominal shear strength in bearing type connection. So, ang iyahang kuan is for KSI, ang kanin siya daw, ang kaning nasa gaw sa parentheses muna siyang KSI. Ang kanin sunod sa parentheses muna siya ang MPA. MPA. So, nakakuan man ta English system man ta. So, ito gamiton is kani 27. So, balik ta diri muna siya nga atong FNV now is 27. So, Rn is equal to, ang atong na-solve nga, kay dayon, 0.4418. So, ang product ana, muna itong Rn, which is our nominal shear strength, which is 11.93 kips. So, ang kanina nga value is smaller na siya sa bearing strength at its whole, which is, ang atong na-solve ngayon na nga, 28.55 sa isa ka whole, and 39.15 para sa isa ka whole. Ang ato ang na-solve diri is 11.93 lang sa isa ka whole. So therefore, ang total nominal strength sa katunga sa kaning bolted connection is, since na may duha ka whole, so 11.93 plus 11.93, so nominal shear strength is equal to 23.86 kips. So, pag-solve na to sa iyang design strength, di ba gay na ang design strength is equal to VRN equals iyang resistance factor na 0.75 times ang ato ang Rn, which is 23.86. So we have that for the LRFD design, the design strength is 17.9 kips. Whereas atong ASD, the allowable strength is Rn over omega. Ang ato ang omega or the safety factor is 2. Dayon ang ato ang Rn is 23.96. So ilahang quotient is 12 kips. So na natin LRFD nga 17.9 kips and itong ASD is 12.0 kips. So next is for group A bolts with the thread in the plane of shear. Ang kani siya, ang pagkuha to sa FNV analaya mo sa table. Mo ni siya katong diri sa kani group A. For group A bolts nga iyang threads daw kay not excluded or not excluded from shear planes. And iyang nominal shear strength with diri which is 54. Dapat 54. Yeah, 54 sa sakto. Moto siya itong gamiton. Then, Rn is equal to 54 times ang cross-sectional area which is 0.4418. So, Rn is equal to 23.86 kips. Then, ang kaning 23.86 is still mas mubog gyapon sa itong bearing strength at each hole. So, i-add to ang duha ka nominal strength sa duha ka hole sa ato ang bolts. So, Rn is equal to 47.72 kips. So, for LRFD, the same process, VRN, which is equal to 0.75 times ato na-solve na nominal strength, we have VRN for LRFD equals 35.8 kips, and for ASD, we have 23.9 kips. The next is from group C, where ang ato ang threads kay wala daw siya sa plane of shear. Diri ni siya sa, maganda to sa table, diri ni siya na belong when threads are excluded from shear planes. And makita na diri nga, iyahang nominal shear strength is 68 KSI. So, sakto ba 68? Nara. So, ang ato ang nominal shear strength is FNV equals 68 KSI. So, ato ang nominal strength current is equal to 68 times the cross-sectional area of the bolt, which is 0.4418. So, atong nominal shear strength para sa isa ka bolt is 30.04 kips. So, at the hole nearest the edge, the bearing strength of 28.55 kips is less than the shearing strength of 30.04 kips. So, di ba gay na nga, ang kani siya nga bolt, ay kani siya nga hole, ang kani siya nga bolt kay, yung bearing strength is 28.55, which is mas gamay kaysa kani. So, therefore, ang ato ang gamiton is kaniyahang mas gamay nga value, which is the bearing strength. So, muna siya itong igamiton diri tapos ang ikaduha is mas dako man ang atong bearing stress then kaysa sa atong na-solve nga shear stress shear strength wait ibalik na to ha natay 28.55 para sa kani dayon ang isa is 50 sa wait na mo siya 39.15 para sa diri then atong na-solve nga shear strength kay 30.04 so less than 39.15 so atong ias is atong gamiton is 30.04 kips. So Rn is equal to 28.55 plus 30.04 which is equal to 58.59 kips. Then solve na sa iyahang LRFD for the design strength and ASD for the allowable strength. So for LRFD we have 43.9 kips and ASD 29.3 kips. Okay, so for the next example, a plate 3/8 times by 6 is used as a tension member to resist a service dead load of 12 kips and a service live load of 33 kips. This member will be connected to a 3 and 1/8 inch gusset plate with 3/4 inch diameter Group A bolts. A36 steel is used for both the tension member and the gusset plate. Assume that the bearing strength is adequate and determine the number of bolts required based on bolt shear. For getting an example, first is isolve sa lato ang factored load. Una ko na to ang LRFD. Sa LRFD, we have factored load 1.2D plus 1.6L or D for the dead load, L for the live load. So, the factored load is equal to 1.2 times the dead load, which is 12, plus 1.6 times the live load, which is 33, and that results to 67.2 kips. Then, i-compute din nato ang capacity sa isa lang ka bolt. It is known whether that the bolt threads are in the plane of shear. So, conservatively, assume that they are. So, matong gingon gain na nga, if wala ganing gi-indicate sa problem, if ang bolt threads ba kay naa ba siya sa plane of shear or wala, ato lang i-assume nga naa siya dito So, the nominal shear strength is therefore Rn is equals to FNV times AB. So, atong gamiton diri nga value sa FNV is katong naa siya sa plane of shear which is 54. Di na to gamiton tong 68. Dito rin siya gamiton. Kanya itong gamiton when the side are not excluded. So, are not excluded meaning naa siya dito siya plane of shear. So, man gamiton 54 nga para sa ato ang F and V. So we have now Rn equals 54 times 0.4418 nga a cross-sectional area sa ato ang volt. So we have now 23.86 kips for the nominal strength. And ang atong design strength karon is just the resistance factor times the nominal strength, which is 0.75 times 23.86, which is equal to 17.90 kips per bolt. So, kada bolt ni siya. Then, isa naman ka bolt atong gisolve to ani. So, next is, isolve na to ang number of bolts required, which is the factored load all over the design strength na atong na-solve. So, 67.2 over 17.90 kips per bolt. So, we have now bolts. The result is the number of bolts, which is 3.75 bolts. So, round up na to, we have now 4 ka 3/4 inch diameter sa group A nga bolts. Next is, isolve na to siya, pero naka-ASD for the ASD. So, ang nato ang factor dead load plus live load, which is equal to 12 plus 33 equals 45 kips. So, compute the capacity of 1 bolt. This is sa previous gibuhat gaina. Isolve na to ang shear strength sa isa lang ka bolt. So, since wala man gyapon giingon dito ang bolt kay naba siya sa plane of shear or wala, so ato siyang i-assume nga nasa dito So, atong gamiton na FNV lugar karon is 54 kips. I guess I rather. So, ato ang nominal strength is equal to 54 times 0.4418, which is equal to 23.86 kips. Then, ang atong allowable strength is just the Rn over the omega or the safety factor, which is equal to over 2 is equal to 3 volts. So, pag wala sa number of bolts, we have the total load or total allowable load, which is equal to 45 kips all over the allowable strength per bolt, which is 11.83 kips. So therefore, naatay 3.77 volts, and ito siya round up. We have now 4 ka 3/4 inch diameter group A bolts. And that's all for my report. Thank you. I get this. Study hard, future engineers.